Hey everybody, it's ET. Part 2 today of Halloween, our Halloween special. Well, it's not really special, just another day, but I got my hats on. So now I'm Sonic, not Amy today, or tonight, because I have a blue shirt on. Okay, cool. So let's get this started. Okay. We'll close this out. Let's get Unity up. But Unity is not our final destination. We're going to be going to Visual Studio, and in Visual Studio we'll be doing a whole bunch of boring coding just for you. So here we go. Alright, so we got Unity up, so that's great. Let's get into some heavy coding. So I hope you like text, because that's where we'll be hanging out for the next hour. Let me start my timer too. Oh, do I have another timer up? Let me close. Wait. I'm confused. Let me close that timer. I need another timer though. Oh gosh. I think I have my timers in my D drive apps. Stopwatch. There we go. Are you using that one? Oh no, it lost the timer. How do I fix it? Do I just do I fix it? Nope, I didn't. Fix the timer, please. Sounds great. Oh man, timer's not working. Oh well. I guess there's one more thing I can try, is actually selecting the stopwatch. Cancel. Let me just get some settings right quick. I know, this is just horrible not actually doing any work. But I want the watch. I don't know why. Why it's so important to me. So basically it's 5. Oh wait, this is not the one I want anyway. Which one is it? This one? Alright. Whatevs. It's not gonna work. I'll have to deal with it. Cool. Well. Alright, let's get back to it. So where are we? What are we doing? PDDL parser. If I build you, you're gonna tell me there's a whole bunch of errors. And here they are. And there they are. Okay. So here we are. We're going to be trying to make a new domain object. So let's go through the code. Alright, so we're going to get a parser. We're not really going to get a parser. Yeah. Or are we? Type parser of will that work? Yeah, type parser. Nice. Okay. And then we could say, hey, get parser. How do we say this? Type parser of t dot create parser. OT. So that's kind of redundant. Let's see if we can kind of get rid of some of that redundancy. So where's my class of parser? I know I tried to create it down here. I think I should be able to just click on this and hit F12, right? Alright, here we go. Type parser. Yeah, I'm just gonna take this out. What about that? Alright, so domain parser. What don't you like? Can't implicitly convert type PDL type parser dot domain parser to I think we established that. Yeah, we established that domain parser is type parser. I mean that the T is a domain, so that's cool. That's alright. What don't you like about this? Okay, I think that's cool. Alright, so, oops. Let's go back to our parsing. So we don't have to create a parser type T. We can just say, hey, create parser. We can, yeah, we can still use you. In fact, we can say null. Yeah, I like it. Alright, so go back to type parser. Here, if you don't have a parser, just return null, and then we know that there's something wrong. Okay, and so we can continue to use this code, parser, otherwise there's a problem. No method exists for parsing t.toString. Yeah, that seems cool. What's wrong? T is a type parameter. Alright, so what if I just said type of T? Get angry at me? No, I think you're good. Alright, cool. I don't understand this whole parser backup thing yet. So I'm gonna just... yeah, I'm just gonna forget it for now. Alright, so we got T object, which I'm just gonna actually rename OBJ. Okay, so T object is not gonna be null, but default T. Okay, nice. So OBJ parser, parse the node, A, let's just do type of T. Yeah, that's cool. And the parsers and the backup, I don't know, so I'm not gonna really worry about that right now. So we got a few more OBJ things we gotta worry about. Go ahead and tab this over. Say this is an is. obj is of type domain. I wonder why you can't convert that to that. You know you're of type domain. Alright, so we're going to return a T of type T node. We don't have to really worry about the class because we're already passing that in. And so parse node. Yeah, it's just a warning. So what's going on here? Okay. So you really want me to pass a type in, so that's no problem. Otherwise, we can't return this, but we can definitely return the default. And what are you? Oh, I guess some kind of semicolon problem or something at the end here. Okay, cool. All right, so parse all, similar. T. What are you trying to return? I think you want to return an array of T, maybe? Like this? It's very possible. Can we just return an empty T array? New T, like this? What don't you like about this? I'm gonna say of 0. Okay, yeah, that's an empty array. List of T. It's gonna be a new list of T. So while that seems to be legit, you're trying to do a bunch of stuff, but I think your intention is just objects dot to array should suffice. Yeah, okay. That is coming together nicely. Define. So define will put or add basically. Yeah, we gotta comment you out for now. Yeah. Alright, so here we're gonna get some type of T. You don't have to pass this around. I don't know what's happening here. I don't think we can use it. I'll always come back and see if we can. I just don't know. Require T. Yeah. Alright, parse all of this. Parse, 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 parse. All of these things belong inside of this thing. This type parser thing. And our goal is to make a new class for each one of these suckers. So let's go ahead. So we are starting here with the constants. So how we're really going to start this off is we're going to have a class. I'm going to call this constant array parser. And yep, it's going to be a type of parser where constant array is where we're going to grab. And yeah, all we got to do is override something. Public override, what are we going to parse? There we go. And how we do that is this. And then we'll come back to fix it. So, okay. That was not too bad. I will come and fix it in a bit. Now let's just keep going though. Class, let's call this operator parser. And we're just gonna override, oh, well, we can't override anything if we don't have anything to override. Let's go ahead and make you override this parser. Override, yeah, this thing. And then we just grab all that code, right? Then we delete this. Save the comment. Let's go ahead and make another class of variable array parser. Don't forget to extend something. Type of parser variable array, and then we just say public override parse, and then we can move that up here. And all we do now is take the stuff. Okay. And we throw it in here. And then we delete all this. And then, hey, we get a problem parser. And that's going to extend problem. Oh, that's a big one. And we just throw that up in here. Oof. Maybe I didn't put it in the right spot. Oh, forgot to override the next part. Public override, parser, all of that junk. That's the place it belongs. And you can parse problems right there. Okay, great. Hopefully just a few more. Oh yeah, there's a good amount more. Alright, no problem. Class. Let's call this a term parser. Type parser. Yeah, right? Like, you shouldn't have a problem with this. Has a problem with this. Is there too many parentheses or something? Not enough parentheses? Yeah, I don't know what's happening. Okay, that seemed to work, so maybe just one too many parentheses somewhere. I will figure that out in a bit. I only see one parentheses here. Anyway, not what I'm worried about right now. Let's just keep going. This can go up here. Public override Yep, this thing, if you don't mind. That's a short one. I like those short ones. And then you can delete all of this junk right here. Class, what do we call this? Constant parser. It's gonna also get the type parser. Oh, doesn't like it. Whatever I'm doing it wrong. Type parser, constant, and basically we're gonna public override constant parse, and we're gonna say node parser, or PDDL parser, and then you get a function, and that function is going to be whatever in this function. Okay, I'll figure it all out somewhere, somehow. I'm gonna come right back to you people. Control KC, Control KD. Alright, where are we missing this? Alright, so open parentheses, this seems to be okay here. Here's some errors. Okay. I'm gonna just comment this whole try part out and just see what happens. Okay. Let's see. I'm gonna comment this part out. Okay. We're going to make a list of constants here. And that means you have a list of constants here. And somehow hey, we got the same function. Good. We're gonna have to make this kind of a class, I think. This is gonna be a, is it in planning IO? Where is this class gonna exist? I don't know. Let's, yeah, let me figure it out right quick. So, settings is where? Settings is, oh, in the main planning. Settings. Here we go. So to do this, I like to just open up something like this and say, hey, public. Nope, wrong one. And here, I like to say public settings test. And then I'm like, hey, generate something in planning. And then I'm like, not really. Actually, I can just undo everything and save that. And then close it. And then go to settings. And I have it now. And I can just paste this here. And I can tab this over. And then all this is just read-only ints, right? Read-only ints. What did I do? I think I made a property. I'll come back to that. Okay. So now we got a default type, which is great. These are lists, so it has to have the app capital. You are putting too much work into that, so that's good. I'm going to comment these guys out. So parser is going to have a parser parse. You're going to have to be an expression node. The name node does not exist in the current context. Why not? Oh, because of whatever I'm doing here. Oh shoot, I see. So we need to parse this variable array. So that's okay, and then that's okay. Okay, and then this is okay. And then, hey, that's okay. Alright, good deal. So KD, awesome. Parses a list of constants. I think that's what you would probably have written. Maybe not with the capital C. Okay, let's keep it going. What did I do? Deleted a bunch of stuff, I think. Alright, so list of variables. List of variables. Luckily we have the starts with thing. Probably have the substring thing too. Awesome. Okay. That looks good. Parse is a problem. I like that too. So parser.require. I don't even think we have that function, do we? Alright, this one's going to be harder, and I see that now. what I do know, if we do use this function, if I just say parse, and then we'll figure out from there, right? Lord, argument 1, cannot convert from string to stream reader. Oh, I see. Alright, sorry. Constant. Just like that. Not sure about all this defining stuff yet. But if we have a list of constants equal a list of constants. Alright, so for each constant in okay, and then what kind of thing? This is an expression? Nice. Expression goal. Cool. So what don't we like? Objects can't be... I thought we had like 2 different ways to do this. Oh yeah, we didn't actually do problem from the Eclipse version, so let's do that right quick. Problem from the Eclipse version, shall we? Alright, so here's the Eclipse version, here's the not Eclipse version. We're gonna go a little off on this. Okay, I'm gonna just go ahead and hit all of those. Alright, this could be string. Yep, that looks good. This just goes up, and that goes colon. And you have to say what type. And I'm gonna guess you are constant. I didn't guess, I looked up. So that's looking okay. What's going on? What's wrong? Must declare what? Yeah, I thought we did. It has a semicolon. Alright. And this is how we're going to override get hash code. It's going to just return name.hashcode.get hashcode. Get hashcode from you. Cool. Oh, I see that we have to have a plan class. Plan is part of what in the original hierarchy? It's part of the main planning. So okay, that's okay. We can just generate it right here. Mutable state should be, I think, in util. So if you do not mind, let's just say public mutable state test, and then oh wait, you already have it. Oh, mutable state is, what am I doing? Alright, so undo everything I was just doing, close that. This doesn't take an initial argument. Okay, so we will do that. If step dot precondition. So are we saying like step and plan are not set? Yep. Yep. Okay. Totally understand. But let's go fix that. Okay, so step and plan. Let's do plan. Eclipse. Plan. Alright, good. It's a short one. Enumerable. I think that's what I need to use. Yeah, cool. And you don't say what the security is on that. Okay. Alright, so that looks pretty good. Now we gotta do step. So step and eclipse step. Okay, so these finals should be replaced with read-only, so that's good and easy. That's a string. You should be using logic. Yep, these illegal arguments can just be argument exceptions. We're gonna go ahead and override string to string. And we're going to do compare to other, compare to the name. Okay, so that's good. And that's it, I think. Great. Alright, so step is done. So good. Now we can get back to PDDL parser. Do we not? Yeah, okay. We'll have to look at mutable state too. Let's go ahead and look at mutable state now, because I don't know what's going on. Where's Eclipse? This one. Mutable states. How's this work? Okay, you extend state, which makes sense. You're gonna go up and semicolon base, delete that, control KD. Are you telling me you're not really implemented yet either, are you? Alright, let's go back to this. Let's get state. We need to do you first before we can do the other one. Alright, here we go. Okay, good. iClonable is something. I wasn't sure. Okay, so this is going to be read only. You're going to be of the generics type. Literals is what? Of literals. That makes sense. Okay. Alright, yeah, that's way too many arguments in here. How about that? Is that better? 2 array. Maybe with one more parentheses. Literals is what? A hash set. Do you not have a dot to array function? Nope. Alright, so this one kinda justified on doing that whole thing. Alright, so we're gonna have to do dot copy to new literal array of size. I thought I could just when I make a conjunction, can I just pass in? I guess not. Alright, whatever. Literals dot, it's not dot size. Dot count, yeah. Back to what I was thinking about. This guy. You can pass in yeah, right, so that should be fine. This, where am I? State literals that copy to. Oh, but it doesn't actually, yeah, I gotcha. Literal array equals this crazy thing. Yeah, this whole thing. Come on, there's gotta be a different way though, right? Literals dot array copy to. You know what I'm gonna do? Literals dot to array, and then we'll figure it out. Because what we're gonna do is now you're gonna be a list. And now you should have a to array function. Bam. Okay. Alright, well, you're definitely a literal and a negation. Okay, so you're just not implementing. That's cool. We'll even get back to you. We'll get back to you, man. Alright. Or do we try to fix you? That just might be an order of events kind of thing. Maybe I make you a negation first. And then you are probably not. Gotcha. Well, like I said, we'll get back to you. Alright, back to states. Alright, maybe not back. Not yet, not yet. Cannot convert from expression to literal. Cannot convert from expression to planning. Okay, yeah, that kind of makes sense. I thought literal was an expression. Yeah, right? Literal is of expression. We'll come back to you. Oh shoot, that's all we gotta do. Okay. Oh, here we go. I missed it. I missed it. I think you really just want to be an object. Oh, and I should totally make you a list, not a hash set. Alright, so if you give me a state to clone, we'll grab the list of literals. Oh, and you're going to try to... this is what we can do. This.literals equals new list of literals. Okay, so we got that list of literals, and all we gotta do is then we just say this dot. Oh, we don't even need to do the this, right? Literals equals a new list, and then literals dot add range, and then we just add everything that was already in there. Okay, so that's good. Phew. So now we can clone it. Now this is kind of where I'm at. So is true proposition. So we got a literal. If it's a negated literal, yeah, I just don't understand what's the hold up here, I guess. So if I say, hey, negated literal prop equals proposition, as negated literal. Okay, that seems to be okay. So that's how we'll handle it, I guess. Proposition as negated literal. Cannot convert from expression. Negated literal equals proposition as negated literal. And then we'll just take all of this and just say negated literal. Oh, okay. So it's basically the argument part it doesn't like, which is fine. Alright, yeah, I'm getting a little tired. Alright, let's see what we gotta do left. I think we're getting through all of this. So problem, back to problem. Here we go. So we got our steps, we got, yeah, so we should be doing pretty good. I enumerable of constant. And we're just going to make a list of constants. And so it's going to be a list of constants. Alright. We're going to have to rename this object to obj just because objects are keyword in C#. And this dot obj. Is it obj here? Oh, it's objects, my bad. Alright, and so we're going to say for each object in objects, there should be a bindings.empty. I'll look into that in just a sec. Okay, and then we can finally do the string override. Override string to string, and we are done with the problem once we get that bindings done. Okay, so bindings, you're saying you can't do it because you can't convert bindings to substitution. So let's see, unify. So this is a term. We are getting bindings.empty. Bindings. We're gonna just say you are a bindings. Okay. Jeez. So we got the problem. And so the problem was important for something. Yeah, I forgot where I was, but oh, for this part. Okay, so that's great. That looks good. Let's keep going. Term parser. Yeah, let's see if we can fix this part. Control KD. Term parse. Try parse. We're gonna do try parse constant. If terms equal to null, then do something. Otherwise, return null. Control K. Control KD. You should be with you. Oh, what's wrong with term? Oh, because we didn't. If it's null, try parse. What are you trying to do? Term? Oh, variable. Sorry. Didn't see what you're saying. So that's good. We're gonna have to do that requires thing, I think. It's not the first one that's doing it. I think you too, right? Where's my requires? Here we go. I think we are. Wait, where are we? Require. Yeah, this one. Okay, so it's just a string. So what do? We get T object. Alright, let's look at get. Returns an object defined by the given name. Alright, so defined. So this whole define thing, I think I need. So, okay. This is going to be a dictionary of string and of type or objects. I don't really know. If it's object, it could just be anything, right? Let's do it. Okay, so that means anytime we see defined, let's do define first. Here's define. Control KU. We're not going to call you object, we'll just call you obj. And then all we're going to do is dot add, right? Okay. So that's not too bad. You don't mind it like that. Okay, that's great. So I don't know what this whole backup stuff is yet. I guess if it screws something up. Okay, I don't know. Dictionary define backup. There's no copy, there's no... How do you copy a dictionary? Let's ask the internet. Do we have a free internet? No. Alright. Copy dictionary. C#. Okay, you just make it a new dictionary. Nice. String object. There you go. That's how you really do it. So we're going to try this. Finally, defined is going to be the defined backup. Don't really know what that's all about, but should work. Alright, so we got defined. We can even do this. Define all is basically going to take params of a constant array, and then we're going to say, hey, for each constant in the array, go ahead and add, that name, the actual object. Okay, cool. And oh, there's another define all. Let's see what this one's about. This define all is, an iterable, which is actually an enumerable of constants. And we could just say for each blank in this, add. Okay, now we can finally look at get. So we're going to have this obj. Oh, it's not actually get, it's just defined name. And if you don't work, just give me the defaults. Else if type is basically not what I'm thinking, but we're basically going to say obj is t, then return object as t, like this. Should I say t like that then? Yeah, okay. Type of, oops. How did I even do that? Type of t. Alright, cool. Okay, so kind of similarly here. Alright, cool. So now we even got all the requires and all that stuff going, so we can define all constants. Nice. That's looking pretty good. Oh, okay. Now we can continue onwards. Class. This one will be a variable parser. Type parser variable. And then we just have to override our parse. And so all of that is going to just be this stuff. Okay, not too bad. That looks legit. Okay, let's keep it going. Let's do this one, which is expression parser. Oof. I'm getting kind of hungry. Anyway, let's just keep going. Expression parser. So how are we going to handle this expression parser? Should be that code. Cool. Except not really what I wanted to do. So delete that, and all this stuff moves up. Control KD. Let's get it going. Alright, so try parse. Let's do negation. Alright. That looks good. That looks good. Alright, let's figure out what's going on. Parser negation, if it's null, then try parse of conjunction. And hey, if that's null, then try parse of literal. And if that is null, oh, it doesn't matter if that's null. If that's null, then, you know, just return null. Okay, and I'm going to go ahead and start moving these comments up a little. So this is the variable parser comment. Oops. This is the expression parser. And I can kind of delete these two. Alright, we got a few more things to do. I think I'm going to just uncomment all of this just so it's a little easier for me, because we're getting to the end here. We'll call this a literal parser. type parser of literal public override. Yep, this parser. We're going to parse that. We definitely got to pass in the classes this way. Gated literal. Predication. Literal. Is a predication, right? I don't know if I have my graph up. Let's get my graph up right quick. Oh snap, what happened? Is that just me? Okay. I think it's this thing, right? Logic code. Oh no, predications of type literal. Interesting. Alright. Alright, well, that's a little off-putting. Or maybe we just didn't do predication yet, and that's what's going on. Yep, figured. So predication is something else. Here we go, predication's here. Yep. Alright, good deal. Oh my gosh, predication's so long. Alright, here we go. Let's do predication. Alright. Okay, just looking around, predication, so this needs to move down, this goes up, this goes like this. You are saying params term array like that. You're gonna have to say what kind of array you are, so you're something like that. No semicolon. Alright, so for your override boolean equals, or is it equals like this? We're gonna say this is that, and then this equals is probably gonna have to be the big one. Yep. Hash code. Now I realize there is an actual get hash code function, which I didn't know. And so predicate dot get hash code terms dot get hash code. Okay. Alright, so we got the toString. Oh, we gotta do this compare to. It's gonna be like this, and this will be is. It'll be a capital compare to. Else do the base compare to, like that. Excellent. override bool is ground. This is going to be an N. Oop. And this is going to be a for each. You're going to have to return an immutable variable term. Override. You can't override. It has to be of expression. Okay. And so that's fine. And you're going to have to be of bindings, like you said. Oh, and is testable, sure. Override is testable. And override is true. Is imposable. Impose. And why not? Predication. Hopefully we'll see it soon. Okay, once I get this whole function going. Negate. Negate it literals. We'll have to take a look at it. Override. 2CNF. Override. 2DNF. Alright, what are we messing up here? Negated literal is less accessible, so you're just saying less negated literal. We didn't actually do negated literal is what you're trying to tell me. Alright, so what's negated literal look like? Okay, it's extending negation, implementing literal. So it'll be read only. Okay. It's gonna be base. Something else is wrong with this. Negated literal. Oh, yeah. That looks good. This is what I'm gonna do. I'm gonna find anything that looks like this. I can't. Alright. See if I can just handle this one at a time, but quickly. That looks pretty good. Yep. What don't you do? Okay, I think I got it. Cannot convert from negated literal to literal. Yeah, that kind of makes sense. Alright, so what are we missing here? Base. Interesting. Let's go back to mutable state. State.state. Okay. I just realized that some of the stuff isn't implemented yet, so I'm working on it. There we go. Mutable state is done. State is done. Negated literal. State.impose is done. You should, yep, return an expression. Okay. Predication by expression. Okay. Cool. Yep, you definitely parse literals. Everything else is, I'm done with it. Let's parse some negations. We'll call this negation parser. Type parser of negation. And then public override this. Okay. Here we go. So you're gonna try parse negated literal. If negated literal is not so good. Oh, if it is fine, then just return it. Otherwise, you're gonna say node as list22, which I don't really know what it's trying to do, but haven't been paying attention to it, so that's okay. So here we go. We're done with that. Class. What's next? Conjunction parser. Conjunction parser. Type parser of conjunction. Okay. Public override parser, and that's the parser. Alright, cool. Oh wait, what about this negated literal parser? Missed it. Negated literal parser. Type parser of negated literal. Public override. Parse. Delete that. Bring this up. And then let's just grab this. Okay. Alright, cool. So parse. You want to parse the literal. You want to parse the expression. Put everything in order. Then let's just go ahead and keep going. Class, predication parser. Override. Yep, this. Alright, cool. So, oh, is that it? Oh my gosh, I can't believe it. I'm like in awe right now. Yeah, I don't even care. I'll find these comments in here. Parser in IO. Constant parser. Parse terms. Parse problems. Oh my gosh, so much parsing. So okay, where are we screwing up so far? If I hit F6, let's keep going. Formula, unify, right? Oh, you don't actually have to do what I'm saying, like the override. So just say bindings unify. Okay, that's cool. Let's keep going. Predication does not implement interface literal. What are you missing? Literal negate. Negate cannot implement literal negate because it does not have. Okay. Okay, so you're hiding something else. So if okay. We're gonna get through the syntactical errors first. So you okay, I think I remember. You don't like to be I don't remember. Proposition is a literal. Argument is a expression? So negated literal is supposed to have a literal, but then a negation has an argument. Gotcha. Yeah. Alright, so we're gonna have to say as literal. Not that it really matters. Maybe it does. I don't remember. Okay. Negated literal. Alright, so what are we not implementing? Negate. Is that okay? I think I see it now. Okay, cool. Just keep it going. Gotcha, yeah. So this is how I'm going to handle it. I'm going to find the substitutes. And then control KD. So the substitute seems fine. What about the negate? Yeah. Okay, cool. Keep it going. Predication. What do we do for simplify? We don't do simplify? Okay, simplify. Let's figure it out. Let's go to literal and make this true. So we gotta make this public static literal true. Whew, man, I am losing focus fast. Might need to give it a call in a bit. Okay. How many errors do we have? 4 errors? I think I can handle these 4. Okay, that one's an easy one. Good. Yeah, some of these are easy, which is, thank God, easy. Alright, I think this is the last one. Let's do it. This is me trying to do it. Alright, what I want to do, I'm sure if I hit compile, it goes just fine, but I do want to finish this simplify, or this literal true-false thing, so let me finish that up. So that's okay, that's okay. So, okay, when I'm making a literal, there should be a true literal and a false literal, so, maybe class view will help me with this. So we have planning IO, planning logic, literal. Literal is an interface, so this stuff won't really fly. Let's look at the picture. I need to look at the picture. So this is the picture. So literal is still an interface. So within literal we can make so it's negated literal. Oh my gosh, where do I do it? In predication or literal? I could put true in predication and false in negated literal? Maybe? I'll just do them both in predication for now. Alright, I'm gonna do it in predication. I don't know where else to do it for right now. And I can't make this an abstract class because you can't inherit from 2 abstract classes, right? C#, inherit 2 abstract classes. You can't, right? Alright, let's go. Let's go back to this. This is how I think I'm gonna handle it. Okay, I think I'm gonna take a break, but we are ridiculously close. I think. PDDL parser. So how do we parse things? We got all of this. So if we do parse, so we get a parser of type T. We create the parser. Oh yeah, when we create the parser, that's when we gotta actually start doing things, right? Alright. Whoa, what happened? I'm gonna try to collapse these just for now, so I can kind of easily see what's going on. Why do I feel like something's missing? Alright, anyway, something is missing. Some classes is in some other class, which is okay for now. Else if type of T equals type of, so we did domain, let's do constant. Turn new constant array parser as type. So constant array seems fine. What about operator? Operator. Okay, operator looks good. Variable array. Variable array parser. Okay. And then problem. So that's where the problem was in problem, which makes sense, I guess. Alright, so here we go. Here's all the other ones. I'm gonna try to just take a snip of this. Snip. There we go. I can just put this on the other screen for right now while I do this. Alright, so we got variable array, which I think the next one's gonna be problem. Okay, so then we got, oh, we lost whatever we were trying to do. Alright, so this is gonna be problem. Here, I'll put a space in here just so I know. Problem, term, constant, variable, expression, literal, negation, negated literal, conjunction, and predication. Okay. So let's go. Problem. I'm just gonna go through the list right quick. Problem, term, constant, variable, expression, literal, negation, negated, literal, conjunction, and predication. Okay, so now we can just look at this while we do it. So this is going to be a problem parser. Could be a term parser. This will be a constant parser. This will be a variable parser. This will be an expression parser. This will be a literal parser. This would be a negation parser. This will be a negated literal parser. This will be a conjunction parser. And this would be a predication parser. Okay. I think I'm gonna take a break. I think the next one, which might be tonight, will be my final one, and I think we'll get it. I think it'll be the best thing we can do. I don't even know what I'm saying. I am kind of mind dead. Alright, see you guys. Bye. What am I doing? Close all of that. Oh, yeah. I'll say bye to the